Hello, Assalamualaikum warahmatullahi wabarakatuh. So we are from Group G. We're presenting about magnetic field reduction screening system for a magnetic field source used in industrial applications. So our group member is the first one, Siti Nurul Ain. Next, we have Marina. And finally, we have Farhan, which is myself. So for introduction, for our proposal project, the dangers that electromagnetic field pose to human health are discussed in this statement. European authorities set exposure limit despite conflicting scientific evidence linking them to ailment. The article describes an industrial procedure that demagnetizes workpieces using an electromagnetic coil and introduce magnetic screening to keep magnetic field that are released within acceptable bounds. The goal is to screen external magnetic flux without changing the field strength at the coil center while preserving the coil functionality. So figure 1 shows coil with workpiece and magnetic flux line. Next, I will pass to Marina.
My name is Marina binti Halim. I will present problem statement. An industrial coil demagnetizes workpiece in an industrial context to get rid of undesired residual magnetic fields and avoid problem with functionality after installation. Through repeated polarity reversal, the magnetic field is systematically reduced during the demagnetization process. This can be accomplished by physically or electrically removing the workpiece from the magnetic coil while gradually lowering the magnetic field. The coil generates a field strength of about 10 kA per meter at its center when it is coupled to a 400 volt low voltage electric network. A magnetic screen is installed to address the extended field intensity in the vicinity of the coil. Effective removal of remaining magnetic field from workpiece during the industrial process is ensured by the screen, which shield external magnetic flux without changing the field intensity at the coil center. We have three procedures, which is initial measurement, design of the screen, and the final measurement. For initial measurement, this measurement enables the determination of the starting state in situ under typical circumstances. 13 sites in all were controlled for the registration of the magnetic field data. And the explanation of the design of the screen. Because of their magnetic qualities, iron and aluminium were used for a magnetic field screen with a 2 mm thickness to balance weight and field reduction. The first trial, which used one iron plate on each side and was positioned close to the coil, did not result in a diminution of the magnetic field. A second iron plate placed 5 cm apart on each side greatly enhanced decrease in one direction. Limitations were addressed by enclosing the coil with aluminum wings at a 60 angle, which produced a final design that successfully distorted the magnetic field. Limit observance was confirmed via simulations and the built-in screen was fitted.
Okay, my name is Siti Nurul Ain and I will proceed about the procedure. Okay, I will explain about final measurement. Measurements were made to assess the magnetic field screen efficiency once it was designed, constructed and installed. In certain areas such as point 9 close to the course axis, the screen increases intensity by deflecting some of the magnetic flux line while absorbing and confining others. But the main objective, which was to lower the magnetic flux density below 100 T at every point, was accomplished with reductions ranging from 88% at point 1 to 20% at point 11. The screen distortion is responsible for variations in the reduction percent. Okay, next. Okay, in conclusion, measurements and simulations have been used throughout the entire magnetic screen design process. In the most crucial locations mentioned in the original scenario, the magnetic field reduction obtained with screen installation surpasses 88%. To achieve such a significant reduction, the proper selection of the relative position and the blending of two types of materials have been essential. Okay, that's all for us. Thank you.